Good afternoon, class. Today what I'd like to do is to go over part 2 of our series of videos on forces. So in this video, I'm going to use the more complicated formula to figure out what my weight is here on Earth. Now, in this one, of course, like I did in the last video, I established that my mass is 100 kilograms, or in this case, I'm going to write it using scientific notation of 1 times 10 to the second kilograms. You'll see why I'm going to be doing that in a little bit. So I don't know what my weight is. I know that I'm going to use the Earth's mass as my second mass, which is 5.98 times 10 to the 24th kilograms. And I'm going to use the Earth's radius, which is 6.4 times 10 to the 6 meters. So now I use the more complex formula of F equals Gm1m2 over r squared, which is of course highlighted in blue. And of course, if you notice, I have all of my numbers here in green, like normal. The one thing that you may have noticed is that I have this gravitational constant here written in black. The reason I do that is to remind myself that this is a constant. This is not a number that can be shifted or changed based on location or whatever planetary body I'm at. This is universal. So no matter where I am in the universe, this number holds. Okay, so now that I have done all of that, now that I've set up the groundwork, let us begin by substituting all of the variables in this equation, F equals Gm1m2 over r squared, into with all of the numbers that I've been given in the problem of what is my weight. So G is 6.67 times 10 to the negative 11th. My M1 is my mass, which is 1 times 10 to the second. M2 is 5.98 times 10 to the 24th, and the radius is 6.4 times 10 to the 6. Don't forget that this whole quantity is squared. Notice also that I'm using the shortcut method, which I've referred to in previous videos. So if you're wondering why I didn't put in my units, it's because I'm using the shortcut method. So now here comes the trick. I'm going to do a little bit of what I like to call my shortcut method, or my helpful method of dealing with scientific notation. For a lot of people, this it becomes hard to kind of look at everything like this, and unless you start plugging it into like an Excel spreadsheet or something, it's quite a daunting task. However, using the laws of exponents and some visual cues, I'm going to actually make this problem look a lot easier, because this method does not actually make this problem easier. It just makes it look easier and look more doable, and thereby allowing you to mentally get over the idea that maybe this is too hard for me, because this problem is really not that difficult as long as you set yourself up for success. So what does that even look like? What that means is that I take every one of these decimal points, or these whole numbers, and then what I'm going to do is I'm going to put them to the left of this side of the equation. So my 6.67, my 1, my 5.98, my 6.4 squared, of course, is all relegated to this left fraction over here. Notice I put a very big multiplication sign. I didn't need to, but I did it just to make sure that there was a separation between all of the decimals that I'm multiplying and dividing, and then all of the base 10 numbers that I am multiplying and dividing as well. Then I take all of my 10 to the whatever powers, and then I plug them in over here. So I got 10 to the negative 11th, 10 to the second, 10 to the 24th, and 10 to the 6th, of course, squared, which I write all over here. Now, here comes the part that I don't particularly like, but it is a part of solving this problem, so here we go. What I'm going to do is I'm going to take all of these decimals and I'm going to put them in my calculator. Once I've put them in my calculator, fortunately these give me nice terminating decimals, so I can at least stomach them for now. So I leave them like this, 39.866 over 40.96. Simple results. There we go. Let's move on now to this 10 to the whatever powers. All of this whole fraction looks like fun, right? It is if you have the laws of exponents, keeping them in mind, you'll be able to do these. Because the first law of exponents says if all the bases are the same and I am multiplying them together, the exponents add. So now I've got negative 11 plus 2 plus 24, which comes out to 15. Then I look in the denominator and I say, okay, this is 10 to the 6th quantity squared. So if I'm raising an exponent to an exponent, I multiply those exponents together. So 6 times 2 is 12, and therefore I get this result right here. So now that I've done this, I'm going to look at this and I'm determined in my head, I'm going to leave that until the very end of the problem, because this I already can tell, and even doing some preliminary calculations, you can tell this number is not going to divide very nicely. It's not going to have a terminating decimal. So to avoid me rounding needlessly, I'm going to just leave it as a fraction for now, all the way through until the very end, and I'm just going to deal with this 10 to the 15th over 10 to the 12th fraction and see how that comes out. So as I turn my attention to this side of the equation, I've got 10 to the 15th divided by 10 to the 12th, and by the laws of exponents, if the same bases are dividing each other, then you subtract the numerator's exponent from the denominator's exponent. So 15 minus 12 is 3, which is exactly what I get right over here. So again, I kept my fraction the same on the left, right over here. And then I did use the laws of exponents to get my 10 to the 3rd over here. And notice, because this is the shortcut method, I put the unit over here to signify that I'm getting ready to answer the question. The only reason I wouldn't stop here is because there's a decimal point in the fraction, and I don't like that. But honestly, if you had gotten rid of this decimal point, I would have been totally fine with this answer. This answer would be okay. But I'd also want, because a lot of times people actually like having some kind of number along with this answer. So for this example, I decided to say, hey, I'll actually do, I'll swallow my pride a little bit. I'll suck it up and deal with this fraction here by doing the rounding. And so but notice I put this as approximately. I put this approximate symbol, and the reason I did this was because this is not exactly what this divides into, but it's close enough. So in this case, this comes out to about 0.98 times 10 to the 3rd, which is approximately 980 newtons, which, by the way, agrees with what we did in part 1 of this series, where I got my answer of 980 newtons. So as you can tell, the only real difference between part 1 and this part is this approximate sign right here, because what you can tell is now that I have done this entire problem, I've gone through this entire process, this process is actually a lot more succinct, and it's a lot more complete than F equals mg. But this one, so while you're working on this, just know that a lot of times if you get a really nice round number, especially gravitational acceleration, that's not going to be the end-all be-all acceleration due to gravity. It depends where you are on the Earth. It depends there's a lot of factors that are involved in that. So just keep in mind that's why this answer is actually the better answer, because it is approximate. It's more like 979.9 something newtons, but for all intents and purposes, this is good enough. So that concludes part 2 of the series of forces. Next time I'll be dealing with electrical forces. So good luck in your studies, and may the force be with you.